Hey, beautiful people, how's it going? I already see the comments section going, active, and I'm so happy to see you all back today. Sunday morning, 9:30 a.m. You all are back to learn with me, and I'm so happy to see you all. And I see a lot of, hackers who are coming back, and that makes me so happy. I can see Ashish, Aman, Chetan, and yeah, I'm so glad you all are back. Let's go our usual way. I've already shared the link to the check-in and registration page. I'm sharing it again. I would hate for you all to lose out on the points that you all are supposed to get by attending all these sessions. Again, today I have two consecutive streams. That means after this, I have a mini event, and y'all I knew were waiting for the last mini event. That's I think good. Yeah, that's definitely the last mini event of Global Hack Week Share 2022. So that's gonna be fun. We have Chrome Dino, yes, Chrome Dino indeed, Ashley. And again, we'll be having lots of fun then. But before that, we have a nice live session on embedded systems. I realized that the sessions have become a tad bit too how do I call it, intense maybe. The last time I did them when I did them in Jan, and so this time I really boiled down the things. I was really interested in the things in the past sessions. But then also we're not going to learn RTOS as much as we're going to learn how to learn RTOS. What we're going to do is after I go through some of the slides and starting with the we're going to actually open the IDE. If you missed out on the installation, I can quickly run you through it. It's very simple. Is everyone facing audio issues? Do I need to reset the network? I know there are gadgets. Alright, okay. I'm assuming this for audio issues. That's great. Alright, awesome. So, yeah, maybe in the loop, I know there's a delay on my end most of the time, but then I live in an area where the network is bad. It works most of the time. So, it's right? So, yeah, we're going to learn, we're going to go through some sites, really just about the usual way I take it for the sake of consistency. And now I'm a little concerned. Do all cons are me? Yeah, let me see if I can, I agree. Give me one second, let me check if I can make it better. Let's see. Thank you so much for pointing it out. Let me see if I Alright, so you all can confirm if it got any better, if my voice get any better. Did it get any better? I tried a couple of settings. Please stop me as soon as you think that's again happening. I'll switch to some kind of headphones. Let's see what we do. Alright. Thank you so much for confirming and pointing that out. I hope you all have checked it. If there's an issue there, I know there was an issue yesterday, so we can look into that too before we move on. But yeah, alright. So, like I said, we're going to do a formality of three slides of consistency where we do it into an icebreaker, then we'll move on into our actual thing where what we're going to do is I'll show you the installation process again in case you missed it. Very simple process. You basically just need to add an extension to really go about it. Now, that wasn't the way I wanted you all to learn it because I wanted you all to go the tad bit harder way and learn configure your entire system. But I think for you all to get started, this is a much better way. I think one of the hackers asked me to give a reference to the IT, and I thought, hey, that's actually a very good way to get started. So, with the IT, I honestly don't have to hacker who they were, but I'm very happy that it was enough. Kudos to them. But so I'll show you the installation, and we'll open a project and we'll go through the entire project together. I'm so sorry, guys. Let me see if I can do something that persists for the next 5 minutes. Let me check something that I can. You know what? I'm gonna switch my network. So I might move to for later. So that alright. I would be very happy to this song. It got any better, it got worse. We'll be debugging as we go. Right? So we will do a walkthrough of the project of all the files that are there. And once we do that, we will actually start looking into code. Even codes, and I'm not going to explain you directly what the code is because I've realized that my interpretation is very once. I don't know what to do. You're going to look it up, especially the main configuration command line where I'm going to show you with how much you can customize the entire project for your board. We're actually going to Google some of the words and see what they really mean and see how they are relevant to us in the context of our embedded systems. Alright, uh, is it really still that bad? If it is, I am happy to just kind of take a break here and come back after the program or after the next section because I know there's a lot of bad time after. I'm so sorry, yours. Uh, how do you want to go about it? Do you want to stop right now and you want to take, come back maybe after the or physical section or the or physical section? Would that be better for you all? Or should I just I'm happy to take this because the recording for this. You know what? Let me try that because that's actually a suggestion. So how about I quickly get my headset and I'm going to play also music until then. And yeah, Chetan, I don't think that will help because but that's okay. Let's try this. Let me get my headset first and until then, I'm going to play some music while you can. All right, is it any better now? I am happy to try any other way that works better if it isn't better. Better? All right, someone says it's better. If it's not, we'll see and figure out another way. Awesome, awesome. All right, great. Thank you so much for debugging with me. So, yeah, I had a lot of problem with my system in the morning. Also, it turns out it was the internet problem, not the system problem. And I've been switching systems, and I have all my material all over the place. So it's gonna be fun while we walk through it. But yeah, basically, so that's what we're gonna do today. I hope you all got what I was saying earlier. Is basically we're gonna look into the slides, a couple of slides, a little formal introduction of me, we'll do a little bit of an icebreaker in the chat. Y'all are already doing great in the chat. I usually do it to, kind of get it. moving and people commenting on each other. It kind of gets the community vibe going. But you all are already doing great. We'll do it anyway for the sake of consistency, and then we'll dive right into the project and we'll stay in the project now. There are so many terms that are going to be thrown at you today. So try and remember them, try and associate them with each other rather than trying to remember what the word really means or what the term really means, because it's much better in terms of recollecting later, by recollecting one from the other rather than remembering the entire definition itself. So yeah, all right, let's do that. So I'm going to start sharing my screen. Give me 1 second, let me find my slides, assuming I find them today. It's been an interesting morning for me, to say the least. All right. So if we do get time today, I don't want to again make it a heavy session. I usually like to keep. I've learned to keep it really light and short and sweet. So if we do get time today, we'll also talk a little bit about product thinking when it comes to embedded systems and IoT. It's kind of one of my favorite topics to talk about because I've seen and worked intensively in that area. Where there's a lot more product thinking going on than the actual product making. But yeah, so if we do get time, I would love to talk about that. But if we don't, that's also all right. Oh my god, where's my PPT? All right. By the time my PPT loads, let's just start with the icebreaker because we'll just move over the slide. Then, so our question for today. So what we do in our intros and icebreakers, if you're joining my session for the first time, is we technically try to answer and get some perspective, or rather, consciously think of what we already know about the topic we're going to learn. So today's topic is RTOS. So can you all tell me? I've already I've used the word more than I've actually explained it. So let's see in the chat what you all think an RTOS is. So the rule is to comment the first thing that comes to your head, the first image, the first word, the first idea that comes to your head when you hear the word RTOS. Y'all don't think anything when it comes to RTOS? Yes, that is the full form of RTOS, which is great. So, Yash, what do you think when you hear the word real time operating system? Is it my system that's delayed, or are you all not answering? Which I'm very surprised about because you all have been pretty active with the questions in the past two sessions. No one else has any ideas about when you hear the word RTOS? Great, great. So when you hear RTOS, you kind of focus on OS. Pretty great and a very intuitive way to learn things. So good. That's exactly what I want you to do. Correlate things. Awesome, Yash. I hope you did not Google that. That just seems like too good of an answer. But great. Yes, Deepika, real-time operating system indeed. But what do you relate it with? Like, what's the first system, first word, first idea that you correlate the word or the term real-time operating system with? Ashish just thinks RDOS is cool. All right. That's a great way to look at it as well, Ashish. No other answers. You all don't think anything of RDOS is? Nice. I like the relations I'm making, Aman. Great. Real time is correct. How you're relating is it is a little more big picture, but we'll look into that in a bit. This is a very good way to look at it. Live OS. Yeah, sensors. Great. So that's exactly what I want. What's the first word that came to you when you heard? So you thought of tracking sensors. Great. All right, awesome, y'all. So yes, RTOS is all of these things that you mentioned in a way, of course, because you all have a very good intuition when it comes to hearing technical terms. Because you're not learning technology for the first time today. You've been using it, and there are so many terms that come across when you're learning one thing, and you already have a pretty good idea before anyone starts explaining it to you. All right. So yes, IoT is not the biggest part. Ironically, because if in case you joined the sessions that we took earlier, we really defined what's an embedded system, and then, so let's start. Let's just rewind and let me quickly walk you through what's an embedded system. All right. So an embedded system, again, I'm 100% sure when you hear the word, your intuition is already telling you what it is, and you have a pretty good idea. But what embedded system really means is a technical system, or rather a small brain, a dumb brain, if it has to be, embedded into systems, right? So your laptops, your remotes, your TVs, your washing machine is my absolutely favorite example to give when it comes to embedded systems. And if you have joined my IoT session, you all know the smart bulb is my favorite example when it comes to IoT. All right, so these are two of my favorite examples to give in these scenarios. So all of these are embedded systems, right? And what makes an embedded system different from a normal GPOS, or when I say GPOS, I mean general purpose operating system, or your normal systems? Well, the embedded system has a lot of functions, a lot of things that don't really require logic as much as they require scheduling, right? They need to be done at a certain point. For example, your washing machine. However smart you make it, it does not make sense for you to have a sensor or an algorithm to check whether your clothes are clean. It makes more sense to know that, hey, 20 minutes of spinning and 10 minutes of rinsing should actually do the job. So what you do, instead of checking, installing sensors and creating logic to make your motor run according to the sensors, what you do is you time it, right? You time it that after 10 minutes this should happen, after 20 minutes this should happen, after 5 minutes the surf should be, the water should be flowed from this compartment so that the surf goes in. So these things are timed, and this timing is what is called real time operating system, right? Because an RTOS helps you really write your logic based on time rather than other actions. So it makes sense for you to check whether there is water or not in your barrel, in your I hope I'm using the right term, but the basically the bucket that goes around in your washing machine. So that barrel, if there's water, you can check that, because that's quite important if you are for the function to be completed. But it doesn't make sense for you to check whether the water is clean, whether the water has what TDS the water has, and things like that, right? So that's right, Yash. So great example. Last time I was really struggling with how to explain what's a hard RTOS without confusing you all, and this is an amazing example. So there are multiple. So when you Google RTOS, and you'll see there are different RTOSs. Thank you so much, Rush. Drum, the washing machine drum. That's the word I was looking for. Thank you so much. And so yeah, last time I was, so if you Google the word RTOS, you will see a lot of things listed, right? So first you'll get a lot of RTOSs that exist, basically, that have a lot of boilerplate code, and you can just build upon it. You don't have to write all the configuration from the scratch every time. So you'll get free RTOS. I like to talk about Zephyr. Then there is Yocto. So there are a lot of amazing, and most of these are open source projects. Okay, so these projects are amazing, and the thing is, why do you need so many different types of projects when they're doing essentially the same thing? Well, there are tons of controls that go in hardware, right? How you're handling different problems, how you're handling different optimizations. I don't think I can ever tell you how important optimizations are, right? From the hardware perspective, from resource perspective, from a product perspective. So when you look at this up, you'll see that there are types of RTOSs. There's hard RTOSs, there's firm RTOSs, and then there are soft RTOSs, right? Uh, yes, essentially, what happened, I guess, if I was going to cover history of computers eventually, but what I instead do is I'll drop you a link to the book I'm reading, which covers the history of computers very beautifully. So first, we started with an embedded system that just needed something. So your remote, right? It does not entirely need anything to be scheduled, but it's an embedded system nonetheless. It has a much dumber logic which works on buttons, right? Every time you press a button, it sends a signal over IR to your TV, right? So that's a much dumber logic. Then comes a slightly more automated logic where in your washing machine, once you press the button, it does certain tasks after certain time. Automation based on certain logic, based on certain time, is also somewhat RTOS if you're using RTOS. For example, a Python script automation is obviously not an RTOS as much as you using the GPOS to kind of get some work done. Alright? I'm not sure how you're answering the summon, but feel free to ask me if you're still confused. Uh, yes, Yash, exactly. So RDOS are very specific. Again, so what I was talking about was hard, soft, and firm, right? So soft RDOS is, so let's say your washing machine's running, all right? It takes 5 to 10 seconds extra to stop one cycle, or there's a delay of say 5 seconds. It's not going to harm anyone, right? Your clothes might get 10 seconds less or 10 seconds extra of a certain task. It's not making any difference. You don't care. You're not sitting and timing it, but there might be a delay happening, right? What about your TV remote? You don't care if you have to press it twice. Sometimes if the signal doesn't go through, right? That's you're okay with that. It's not harming anyone. But rocket propulsions, like Yash mentioned, if you're using an RTOS there, or if your air brakes, right, your airbags in your car, or your flight emergency protocols that are running on RTOS, they need to be absolutely precise. There's no margin of delay or error that can be tolerated. So those are hard RTOSs. So what happens is, why do you need them to be separate? Why can't you have just one RTOS handling all of this? Because for the timing to be precise and for the timing to be absolutely accurate and your tasks being prioritized in such a way, you have to sometimes compromise on the resource usage. For example, you cannot have a deadlock ever occurring when there is a hard RTOS. Another thing about hard RTOS is that you'll probably want to keep things simple. That entire system will probably only run that particular task and it will be absolutely precise. So RDOs can be doing a lot of other things. For example, again, your washing machine, it's checking for the water level, it's constantly, monitoring and, maintaining the water level by replacing the water. There are multiple things happening apart from the scheduled thing, right? It's also checking that, making sure that the 20 minutes are over. So that is not soft, but rather a firm RTOS. It has a timing, it does it pretty accurately, but you don't know and you don't really care whether there's a 5 to 10 seconds of delay, but that's the maximum delay that'll happen anyway. Okay, if there's a more delay, then the system's wrong. There's something wrong with the system. All right. Let me quickly get back to the comments. Yes, yes, Deep. So all the events have been recorded, regardless of them being recorded. I'm available on Discord. I'm also staffing the FPH next weekend, so come say hi if you have any questions or if you want me to explain anything. I'm happy to do that. All right. Well, that's how it started, Ashish. With a simple yes or no system, dumb circuits basically doing. Let's say you had a simple task that you could, just put it onto a system and you did not require any more brains. So that's how it started. But that's not how it works anymore, because today you have these beautiful and amazing sophisticated boards. I'll show you some of I'll do a little hardware flex in a little while, and I'll show you how beautiful the boards today are and the amount of power that comes with every board. And let's see if there are any more comments or questions for me. I am staffing the FPH. So the hackathons that run on the MLH Discord server and the MLHers run it basically are called FPHs, first party hackathons. And I'll be there on the weekend in the Discord server basically all day to just answer any questions you have, or if there's any way I can help, right? Oh, absolutely. You know what? Let me drop a link to our FPH happening next weekend, and you're gonna love it. I know for a fact are going to build some great hacks too, because I know some of you who join the hackathon and submit to hackathons, and I know how amazing your projects are. So let me quickly drop a link before we continue. Assuming, oh, my PPT sorted as well. Awesome. So I'll share my PPT right after I drop the link. So it's called Hero Hacks, and basically every weekend we have a slightly open-ended theme, and you can join us there. Oh no, Aman, I'm pretty sure you must be aware of it if you've been on the MLH Discord server long enough. So I've dropped the link. When you see it, I'm sure you'll know how it goes. We have some mini events, but they're run on Discord, so they're way more interactive, and everyone basically gets to talk. Yeah, so I've dropped the link. Well, Ashish, you're more than welcome to the community, and I am looking forward to seeing you in our future FPHs and live streams. All right. So let me now share my PPT finally. So, all right. Until then, though, if there are any questions about what I've said, if there is still any confusions about what's going to happen, all right. Am I audible? Mayol, in case you can hear me, we're today discussing embedded systems part 3. This is basically a last intro session into embedded systems where you can figure your project if I don't lose out on my connection again. And basically start understanding how. Thank you so much for confirming, everyone. I really appreciate it. I'm so sorry about what's happening today. Let's try and power through. Once I share my screen, once I share my project, I just turn off my the bandwidth is kind of saved. I have no clue why my internet is being so it's not great at most times, but today it's just being unusually mean. So let me uh stay put. If it gets all bad, what I'll do is I'll stop it and we'll later in the day. I'll definitely make an announcement and it's Mary won't be able to reach. It's too late for her and she's going to be doing the closing ceremony in the morning, but I'm going to figure out a time among us and we'll get back on stream then. All right, let's go through for another 5-10 minutes. We'll move it later in the day. Am I audible? Am I still audible? Please, please. All right. Is it still there, Chetan? Can you please confirm? I'm not too worried about the video, quite honestly. I am though worried about the audio. So if y'all can hear me, I am good. I'm okay. a little distorted, a nice image for you all to remember when you think of embedded systems. But I am worried about the audio set. The audio is clear, we can continue and we'll just power through. When it comes to the VS Code, I'll just stop my camera then, and that way we'll be just fine. Awesome. Thank you so much for confirming that I'm audible. Really, happy about that right now. All right, so let me quickly share the first few slides. After that, we can just power through with the screen. Okay. Again, it's supposed to be super light and fun session. Like I mentioned, what I'll be doing next is we'll actually just look at new words, Google them, and understand what it means. I'll try and give you a little perspective before we Google them so that you all don't get confused with what definition pops up. I don't know what we're expecting. It's supposed to be fun, it's supposed to be a little quirky, and it's supposed to be basically making it memorable for you all. So let's see how that goes, and please confirm as soon as my screen's visible to you all. At this point, I don't even trust my system anymore. All right, so we are through with this. We're through with this. Let's talk a little bit about me for like another 1 minute. You all already know me. I know you all are all amazing hackers who already been on all my streams, but a quick overview from more of a why I'm doing embedded system streams point of view. I have a pretty extensive experience in IoT and embedded systems. I've done almost 4 internships in them. So I write firmware. Essentially, what's firmware? In case you all aren't aware, firmware is the software that goes onto your hardware, and that's what makes embedded systems. And if you all ever joined the IoT stream, or you can look up the recording, we very clearly, there's a, if you imagine a circle, embedded systems, IoT is a tinier circle inside that. So almost all IoT systems are embedded systems, but not all embedded systems are IoT systems. All right. So I love communities. I love interacting with all of you all amazing people, and that's how I ended up as an MLH coach. And I am also a hackathon veteran. I've made mostly hardware projects, and yeah, I'm happy to connect with you all on any of the links. Now, Ashish has asked this question, and that's a great question, Ashish. So there's a fun story to it. I the first thing on my intro, it says I'm a maker. So what's a maker? Just to give you a good idea, is basically I do all these weird, quirky things where I mix LEDs with my art and my art with LEDs, and basically just like mixing things up and making new crazy stuff. And if you all joined my art plus technology stream, you saw how I do it. And I like maker spaces, and I think halfway through my first year of college, I looked up maker spaces around me, and I found this really cool maker space slash hacker space really close to my place. I ended there. I was an obnoxious first year old. I was in Robocon, and I was like, I already know a lot of engineering. And I'm like, hey, you know what? I can do a project. Just give me a project and I'll complete a project. And it turns out I wasn't that ready to be doing that project by myself. It took me, and that's where I first came across embedded system as as firmware writing as a career. And I ended up writing firmware for them. Never completed it though, because it was really difficult. And I came across Zephyr for the first time, and it was incredibly intimidating for me. But yeah, that's how I got into embedded systems, and all my internships after that just happened to be in embedded systems. Like, I was pretty open to hardware designing as well. I actually wanted to try it, and I want to still. I mean, I do a little bit, but I want to go into it more professionally. But for the time being, I'm good with firmware. I have great stories associated with firmware, so I'm sticking to that for the time being. Exactly. So we won't be going to that slide today, but I do have a slide which says and compares RTOS to a GPOS, and yeah, exactly. That I think will give you a good idea about what we're going to be doing. All right. So this is what we're going to be doing today. We have intros and icebreakers, which we're already done with. Outcome is what we're looking at right now. We've already discussed what is a real-time operating system, but what I want to do is I want you to look at the slide that compares RTOS versus GPOS, and then we will look at setting up our project, how to go about installing the IDE and setting it up. It's a very simple process. It'll blow your mind how simple the process actually is. And I would really like you all to follow along. If there's any trouble, I can help you then. And we'll again look at this thing called getting started and staying put. Basically, how do you make sure that once you've started your journey into something like this, you don't drop out just yet. All right, I know it's a difficult journey because hardware, working with hardware can be a little overwhelming, because you need to make sure you know the data sheet, you need to make sure you understand the hardware specifications, you need to be able to configure the hardware specifications. But it's so much fun once you get through even the simplest of the projects. And then we're going to look at exploring our project, which is basically our main aim today. We're going to spend the maximum time doing that, assuming again I don't drop out. So let's get right into it. All right, let me see if I can find the slide right away. Oh, what? Let me stop sharing. And all right, I want to share my screen again. So I think this will really give you perspective about what's RTOS versus GPOS. Also, if there's an audio issue at any point now that we're sharing the screen, I'll just turn off my camera. Let me know. Uh, this is an amazing question. I'm so glad you asked. So what I usually do is I talk about device architectures. So when you say from one microcontroller to another, if it's the same architecture, it is the easiest thing to do, because if you work extensively with one chip, the other microcontroller basically is just another version of the chip. But if you say microcontroller from the chip point of view, like when you say from, so if you're telling me from Uno to Mega, Arduino Uno to Mega, that's the easiest transition. There's basically no transition at all. But if we're talking about it from an Atmega chip to an ARM chip, then yes, there's a lot of differences. There's a lot of how do I put it? The complexities change basically. Your resource management changes. But if you know how to work extensively with one chip, you all know the different specification and resources available. It's a fairly easy task to just go through the data sheet and just compare. Okay, so this is changing to this is changing to this, and just basically configure your project accordingly, right? Then again, then there are levels of microcontrollers. There's application controllers, and there's the very the dumb ones also, like the very very IC based ones that were like just in the beginning to do the dumb work, compare things and just give an output. Those are also microcontrollers, and those are also quite easy to transition from and to. So you will see a lot of beautiful projects on Instructables with a tiny 85 and a tiny 44. I urge you all to look it up, because you all can get the ICs for cheap, and you all can start building projects right out of the box with them. All right. I hope I answered your question, Giant Ball of Yarn. Great username. Yeah. So, any questions apart from that? So you're looking at a table which is comparing RTOS versus GPOS, and I think this gives an amazing idea as to how RTOS is different from your GPOS. So when you say GPOS, let's look at the last line, couple of lines first, right? So let's look at use cases. RTOS is for embedded computing, for embedded systems. GPOS is your normal desktop, laptop, and tablet computers. Let's look at the examples, because once you hear the examples, it will give you a much better idea as to what we mean when we say GPOs, right? So your Microsoft Windows operating systems, your Mac OS, your Linux, all of them are GPOSs. Your RTOS though is what I keep talking about, right? Free RTOS, Zephyr, Yocto project. I've never really used Contiki source code, so that's something new for me as well. So if you all ever work with it, do let me know how that goes. All right. So now you all have a good picture and a good perspective as to what is the difference between an RTOS and GPOS. But let's just look at some features anyway. So your RTOS is deterministic, right? There's no random execution pattern. You can't just press one button after the other, and it's not going to change the behavior until and unless you've programmed it to do so, right? For GPOS, there's dynamic memory mapping, right? So if you open the Chrome button, it'll open Chrome. If you open the next thing, it'll open the next thing. If you close, so that this just happens as you instruct it, right? There's no execution pattern can be as you kind of trigger it. In your RTOS, though, let's take a washing machine. There is no random, right? If you're going to change the temperature will change. If you're going to start, the machine will start. And once it starts, it's going to go through some different algorithms and give different tasks regardless of what the temperature is, right? So it's a deterministic and there's no random execution pattern, right? I think that's one of the first points to be able to differentiate. Then is the predictable response times. You know that the rinsing is going to take 20 minutes. You can come back in 20 minutes and be safe, safely assured that your rinsing is going to be over. Again, GPOs, it's random, right? If the Chrome tab's going to stay open as long as you're going to keep it open, your VS Code is going to keep running until you don't close it, right? So it's a random execution pattern. Again, based on how you're triggering it, right? RTOS is time bound, right? I mean, it's basically us telling the same thing again and again, right? So it is time bound. In GPOS, response times aren't guaranteed. If you have too many things open, Chrome tab might take, say, 5 extra seconds to open, and if nothing's open, it might open like this, right? Like instantly. So RTOS, we can't have that happening. We cannot have the machine, after you press the start button, taking 10 minutes to start the entire cycle. No, you all know that the maximum time 1 minute, else it's going to give you a timeout error and it's going to tell you, hey, either start the process again or look into fixing me, right? Preemptive kernel. What's a preemptive kernel? Well, the thing that we've been saying over and over again, basically we can schedule things and we can have tasks and priorities and all timed, right? We can have priorities of tasks. In GPOs, some tasks do have priority. For example, if there's a power notification, that will kind of override other things and things like that. But it's not preemptive in the sense that it will kind of completely take away the resources from the other tasks and just focus on that, right? It has the capability of multitasking. It has capability of kind of resource management within itself, which is also a very interesting thing to look into. All right. So that was RTOS versus GPOS. Are there any questions at this point, or have I said anything that does not make sense? Because if so, this is basically what I really want you all to have a basic idea. If we look into choosing an RTOS in a bit, but until then, if there is any questions, otherwise we'll move on to setting up a project. We're already almost an hour into it, so let's take some pace because I really don't want to keep you here long. Any questions? No? Am I explaining that well, or did you all just give up on the stream a long time ago? Sure. So when you say for jobs, do you mean how do you show that you know enough RTOS to get a job, or do you want to get a job that makes you learn RTOS? Because both work. So in my case, and I always do this, if you have a makerspace around you, especially if you're joining from any of the metropolitan cities in India or most of the cities in any other, developed countries like the US or Europe, they have the most amazing maker spaces. So if you all are joining from Delhi, Pune, Mumbai, Bangalore, these places have some amazing maker spaces. Look them up. They usually are pretty amazing people there, working very project driven, very idea driven, and they'll be happy to help you out. So, Giant Ball, if you're where are you joining us from? I'll be happy to give you a tad bit more customized suggestion there. So, we look into that. I honestly don't want to cover something so complicated today. I mean, it's not that complicated, but it's more about how they're managing resources. We'll look into how Zephyr manages resources, and then maybe you can compare free RTOS with it. I uh, I lost my connection. But to transition over to my domain soon enough. All right. So since you're joining us from the US, Giant Bolivian, I think you have some amazing options. maker spaces and opportunities available. I urge you to check out the maker spaces around you, and I think you'll be doing pretty well. Okay, now I'm going to ask this question. I'm how good I am. I've had I so many people have told me that that they're doing embedded systems project or an IoT project, and then I ask them what's the microcontroller they're using, and they tell me Raspberry Pi. Raspberry Pi is not a microcontroller. Raspberry Pi, processor. It is basically a chip that you know it's basically a single board computer. Okay, it's SBC. It's called an SBC, and I have enough pies lying around because I always have to. All right, I know for a fact I'm back now, but I'm not sure where did you all lose me because I was disconnected. Am I audible now though? I'm so sorry, y'all. I know this is very irritating, but please bear with me. Matthew, were you around when I answered this question? Did you hear me when I answered this question? All right, in case you all didn't hear it, I was answering Matthew's question. Yes, this is a great question, Matthew, and the answer to this is no, it does not. So I'll tell you why. Okay, so Raspberry Pi is a single. Oh, you heard it? Okay, awesome. You heard the question, the answer to the question. All right, awesome. Alright, so I am not sure where you all lost me. So let's just move on to the next part. If there are any questions regarding what I said, or if it didn't make sense, let me know. And what I'm going to do is I'm going to turn off my camera so that there is no disturbance. Wait, Ashish, did you not hear the answer? Because I'm happy to answer it again and properly. But no, I'm not. I was actually on a optical fiber based Wi-Fi that's not working, and right now I'm using my hotspot. So no, I my Geo hotspot works okay, it's not great, but okay. Oh, you couldn't hear the answer? Well, no, not an issue. I am happy to answer it properly because that's the whole point. And that's a great question, Matthew. So here's the thing, right? The story I told was there's a lot of times people come and tell me, that they're doing an embedded systems project, they're doing an IoT project, and I ask them what microcontroller they're using, and they tell me a Raspberry Pi. And no, Raspberry Pi is absolutely not a microcontroller, which is why it does not use an RTOS. Raspberry Pi is a single board computer, and it uses a GPOS. And how do you verify that it is a GPOS and not an RTOS? Is because remember we spoke about, we can see the examples on in front of your screen, right? Linux operating systems are basically GPOS, and yes, it's basically a computer, Ashish. That's correct. It's literally, you have a desktop and everything. You know what? I can actually power it up and share my screen in a bit. So, yeah, so it can run Ubuntu. It has a 64-bit operating system, which is why it's not a microcontroller. All right, let me see if I can quickly pull out my Pi, which should be around anywhere. There you go. You know what? I see. There we go. I might just power it in a bit, and I'll share my screen. I'll assist into it and share my screen. Yes, Arduino is a microcontroller because Arduino runs. So in your Raspberry Pi, you can just stop a process at any point, redo a process, have multiple processes. Basically, remember we spoke about random execution time and dynamic memory mapping. A Raspberry Pi does that, which is why we know that it has a GPIO, not an RTOS, right? It does have access to GPIO pins, which is what makes it unique and a very normal thing in an embedded systems. Now, remember, an embedded system can have a microprocessor and not just a microcontroller. All right, does that make sense? Yes, Ashish, you are correct. Tiny chips are also microcontrollers. All right, did that make sense? I hope it did, Matthew. If there are any more questions, or if you lose me again, please ask me to repeat at whatever point you lost me. I'm happy to explain again. All right, so I'm going to stop sharing. I'll start sharing my VS Code, and we'll go over the setup. All right, no problem, Ashish. I'm glad you could join in. All right. So I'm gonna share my Chrome tab, which shows how to go about installing platform.io. So let me quickly go here. All right. I hope that's visible. And if y'all can see this, this is how simple this is to go about installing. Let me drop the link here. And while the link reaches you, let me stop my camera, and I'm going to give you exactly 5 minutes. So it's 10:45 in my clock. I'm going to give you until 11 to try and install it. If you're installing it, let me know. It's a damn simple process. You just need to add the extension using the link provided. Once you do that, we can quickly start looking into how the configuration of the project works and how you can go about making and building your own project. All right. So until then, I'm happy to take them. Is anyone of you all installing it or trying to install it? If so, we'll wait. If no one's doing it, there's no. I do not see any comments. Did I lose my internet again? If so, please let me know. All right. Thank you for confirming, Aman. Are you all following along? Is anyone following along? If not, let's move on. All right. Since I see no comments whatsoever, I'm going to assume no one's following along. If anyone is, please ask me to wait. It'll be easier for you to kind of compare what's happening in your project and set up your project accordingly. All right. That's all right, not an issue. It's okay. But if anyone is following along, I don't mind waiting another minute. If they aren't, no one is, it's okay. We can always look into it later. All right. So, ठीक है. Not an issue. So, let me stop sharing my screen. So, this is where I'm going to basically install this. I'm going to go ahead and share my VS Code now and show you how to set it up basically. All right. So, let's do this and open a new window so that you all have no confusions whatsoever. All right. So once you install the extension, this is how it will show up in your VS Code. Please confirm as soon as you can see my screen. I honestly have lost clue as to when you all can hear me, when you're losing out on me, and things like that. Is my screen visible? And if you all are following along, please let me know if there is somewhere you want me to wait. All right. So once you come here, you can see that once platform.io is installed, you'll see this really cute alien symbol of theirs visible. Click on it, and it'll show you all the different options available. What you want to do is you want to click on open, and it'll show you the platform.io home. Pretty amazing interface in every way. All right, so you can see these are the three projects that I have kind of tried, or I was playing around with in stream, which is of course not happening later. All right. So is it still blurry, Aman, or did it get better? All right, I am seeing Uttam for the first time. Hi Uttam, how you doing? All right. Since you all see the screen, I'm gonna keep instructing. If there's any point where it becomes too bad to see, we'll wait for it to get better. All right. So there you go. What you want to do is you can start with project examples. All right. You can either start with project examples or you can start with a new project. You can also import existing projects and you can open projects that you already made, right? That's a fair thing. So you can go into boards first and you can see the amount of boards available, all right? And this gives you a very good idea as to, you know, uh, how many microcontrollers there are, right? So yeah, basically what we're going to be using is a microbit, but we can also use a swan. I have a swan right now, so let's see if they have a swan. There you go. So this is another board. So let me try and see if I can add it. Unit testing, debug. All right. So this is another board. So this is where you can check all the boards that are supported through this embedded systems. All right. So we're going to go back to projects. We're going to go back to home rather. So you can see all the projects that I created. So this is what I was testing in the morning for. This is what we'll be writing our code into if we reach there. This is the Blink example of Zephyr. We'll be reading the code and understanding what's happening here. And if we do get time, we'll also look at the BLE code. It's a beautiful code. It's a very big code. Also, if you click on configure, you'll see all the different options that you have to change through this interface. This interface is very, very nice. Does anyone know here what the monitor speed is? Well, Uttam, no, you haven't missed much. You have just missed a little bit of RTOS knowledge and a lot of my connection issues that we tried to debug together, but you're good. And in case you're confused or don't understand anything, feel free to drop a question in the live chat and I'll answer it. All right. So, what we're looking into right now, Uttam, is we're setting our project on platform.io. We went through the installation. I'm dropping the link again for you. So this is the link you can use to install platform.io into your VS Code. This is an embedded system stream. And what we're doing here is basically trying to set up our embedded system project and seeing all the different things supported. All right. So Aman, great question. Aman, have you heard of the word baud rate? In case you haven't, it's basically your speed at which your serial communication works. All right, and when we say monitor speed, if you're printing something, what happens is if you're printing something on the board, right, and if you're debugging something on the board and you write serial.print in case of Arduino, or in our case printf, what's happening is the board is sending data to your monitor over the serial connection, in our case over USB. So when it's doing that, the speed at which your monitor is supposed to read the data coming is the monitor speed. All right. The number in front of you, which is 115200, is the standard number. If you ever use Arduino a lot, you know Arduino most of the times uses 9600. They are baud rates, and they're basically the rate at which your serial communication works. All right. Did that answer your question, or did that make sense as to what's a baud rate? This is one of the most basic configurations that you can always handle in an embedded systems. No matter how dumb your project configuration is, this configuration will always exist. This is one of the most basic communication and configuration systems that exist. All right, then you can see there's the board ID. All right, this is all configured. The platform is a Nordic NRF51 because uh, I chose Microbit, right? I'm struggling to remember the name. I chose Microbit, which is why our it's automatically configured to NRF, Nordic NRF 51. All right. So let's go back to our home and let's create a new project. Let's put project name GHW, share, live project. That's our name. I take a lot of GitHub workshops, and I always mention this whenever I take one. Is please give good names to your projects. I'm actually very bad at that, which is why I've learned the hard way to do it. But yeah. All right, so let's look at Swan. Does it have Swan? Yep, it does have Swan. And then these are the frameworks available. So you can see Zephyr is not yet available for it because Blues Wireless right now is still working on getting their board added to Zephyr. But until then, we have these two options, and you can choose whatever you're comfortable with. I'm going to go back and choose Microbit. So Microbit, BBC. So you can see it's a Nordic and RF51, BBC Microbit selected, and now we get the Zephyr option. So I'm going to choose Zephyr RDOS. You can use the default location if you're okay with the default location. Otherwise, if you uncheck this, you can create whenever you want. Right? So I'm going to use the default location. I'm going to click on finish, and it's going to take a while to kind of set it up. Exactly. I am so bad at naming things. I've actually, I've been told how much difficult I make the production code base because my variable names now they're a lot better. They're much better than what they used to be, but they're still bad. But initially, my variable name used to be hey one, hey2, hey3, and that's the worst thing you can do to your project because after a point, I used to lose track of what's happening. All right, I have a feeling. Okay, so that's my project loading. So let's wait while the project loads. So is anyone following along? I know Amin is not following along right now. Uttam, in case you're trying to install and follow along, let me know. We'll make sure that you're on the same page. Thanks, Amin. I am proud about it. There you go. Yes, I touch. And this is your project code now, right? This is the entire project folder that platform.io has been kind enough to set up and configure totally from the base. Right. So you have first the board configuration, which is the project checksum. Do you all know what's a checksum? Take your time with them. If there's any question, if there is anything holding you back, we'll make sure we'll come back to it whenever you ask a question. All right. So what checksum? Does anyone know what's a checksum? In case you all haven't attended my streams earlier, I can be pretty pestering when it comes to asking questions. So sure, checksum just as a word, it's a technical word. What is the basic? Why does checksum exist? In sense of anything, that concept is common to wherever checksum is being used. So I think Uttam, if you've asked me in sense of networking, I think you already have a pretty good idea of what's a checksum. So do you want to take a shot at What's checksum? So while Uttam answers, and I'm sure he has the right answer, a checksum is basically to make sure that the data you're sending is correct. It's like a password, but the password has a logic to it. So for example, I think my favorite way of explaining a checksum is if you're using any particular module that is sending data, right? What happens is whether it's over a protocol, whether it's over something as close as an NFC as well, right? Nice out, Uttam. Nice out. Next time I'll wait and I'll best it until you answer, alright? So don't do that. Anyway, so it's basically to make sure that the data you're sending is correct. And how do you do that? Basically, your checksum will have the value which will be a logical interpretation of all the other data. It's usually a two's complement of all your data added up. Alright? Well, see, that's the thing, right? Now you'll correlate it to something and you'll remember it better next time, which is why I like making a little bit of show out of making you answer questions, all of you all. That's a great answer, Yash. I don't know, Yash, why do you attend my streams? You already know so much, man. I mean, at this point, I could totally invite you on the stream and you would be better at teaching everyone. All right, so that's a checksum. Next, we have our CPP properties JSON. All right. So you can see these are these amazing libraries that it's being included that are being already included. All right. And remember that there are some functions here that have been checked. If this is true, then the path will also include this. So you can straight away use these into your code, right? You can use Arduino VC microbit right out of the box into your code. Oh yeah, so embedded system always has a two's complement. So your entire data has a two's complement plus one, and then it's sent over. Trust me, I know it because there was a point I was porting a library into Zephyr, and the entire reason why my code wasn't working was because I never really updated the checksum. And I actually sat down with a notebook and a pencil and calculated the checksum for my data. Fun stuff. If I get a chance, I'll tweet it later today. You might want to keep an eye out there. All right, so these are predefined already there in the JSON, which means you can use all of these variables or just let's just call them for the time being definitions right into your code. All right, it won't throw an error. This is the C standard that's using. So in case you joined the first stream, yes, Yashan, that's an amazing thing to have. Always take credit for whenever you're explaining things right. Awesome. So C standards. C has multiple standards, and I learned this the hard way because in case you joined the first stream, what happened was we were doing a little C crash course, and I am very used to a certain behavior of C, and it didn't do that. It was a tad bit embarrassing, but then we also learned that there are different versions of C, right? And the standard of C used by the system and the priority to which it gives warnings and errors is different in an embedded systems. So the error we faced was, let's say you're using an unsigned integer. All right, if you're using an unsigned integer, let's say an 8-bit integer, it has a range, right? If you give a value more than that range, what happens is it rolls over to the next value. So let's say your integer has a value from 0 to 255 that it can take according to the size that you've given. And if you give the value 300, what it's going to do is it's going to roll over. So from 256, it's going to start taking it as 0 as well. In our case, in our C that we were using, the pure C using the GCC compiler, it gave an error, and I was really confused as to what was happening. So this is where the C standard comes in. So if you ever want to know or have an idea about what's going to happen, look up a C99, and you can see it already has some basic libraries included, like this stdint, which I was forgetting to insert the other day in our code, and an autocomp.h. All right. Also, look at the difference here. This is a generated library, all right, and this is a toolchain library. What's the difference between a generated library and a toolchain library? Do you all want to take a shot at it? What's the difference? I mean, uh, how do I ask the question? Okay, so why would you want a generated library to exist? Why is there a need for a generated library? What's it? Why not just write it before? Anything that comes to your head, why? What is that might be generated after the code that you need a generated library? Apart from your, compiler and linkers working, I like just give me I'm getting right now, but why? No, Yash, Aman, uh, Ashish is gone. Chetan, I don't know if he's still here. No one wants to take a shot at it. All right. So when we saw board rate, right? It's okay. I wanted you all to try. That's okay. It's perfectly fine to not have any idea at all. But remember, every time you hear something, there's often some form of idea that forms into your head. So using that, you all can always make your learning better and memorable. All right. All right. Actually, that's a great attempt. No, the idea when I ask you is to understand what's the thing forming in your head, but that's okay. So you need a generated library because remember, in your board, at a different there are the whole point of us having a completely different software and configuration files for microcontrollers is because we understand that the resources the microcontroller is using, the resources that we might use at a particular time and a time after that could be different. So the LEDs that I'm using in a board, I might not need to use all the LEDs, so I don't have to define all the LEDs. I might not be using the entire potential of the board, so I don't need the entire potential of the board decided or defined, right? I could be not using a lot of buses. I could only be using UART and SPI. So there is an I2C bus, but I don't really need it, right? But what if I want to use an I2C bus? So these things, they're defined in the code. And in the code, when you're like, okay, I want to use the I2C driver. So you call in the I2C driver or you call in the UART driver. And in the generated library, what it does is it marks whatever is being used as true and false, and depending on that it makes error codes. For example, if you say I'm using I2C and then try to use the SPI function, it's obviously going to throw an error because it never really took in the SPI library. It was waiting, it called in the I2C library, it's waiting for you to use the functions in the I2C library. Does that make sense? Then that's just the library point of view. Then your I2C bus rates, your SPI bus rates, your I2C parity rates, and all of these things, right? All of these things are all configured in the generated library because you don't need everything included at first, right? You're going to be wasting such a huge amount of resource if you're going to define all the hardware ports that you're not using, right? So that is why a generated library is a pretty important thing. But it's an also very good idea to always check the generated library and make sure you do not make any changes to the generated library. If you have to make changes to the generated library, or you want to debug, looking at the generated library, you can kind of trace back what you could have done wrong in the code. All right, so that is why generated libraries are pretty cool. And yeah, if you ever get around to configuring your project, do look into it. All right, and then you can see there are some other libraries and compiler paths that have been defined here. All right, again, you're not supposed to make changes here, but let's say you were to add another board that is not mentioned and the configuration is the same. You will simply go here and add and make changes here, right? So this is basically your JSON defining all the properties. All right, then you have extensions because this is using an extension. It has an extension.json, and then this is the launch.json. Basically, it's telling your project and your code where to find what compiler, where to find what tool chain, where to find what library. All right, so you can see debugging when it's asking for debugging, it's requesting to launch. The name is called this. The tool chain is called this, the path is this, and yeah, so this is basically where you can also debug things if you all aren't sure what's going wrong. All right, then is that include. All right. Now there's nothing here because we haven't included anything. This is an empty project, right? Then you have libraries. Again, no nothing here because this is a empty project. This is also empty, but this is for you to understand the structures, right? If you're making a include file from scratch, you will make an include file here and you will add it over here as well, and then in your src you can just call it, right? So include zephyr.h, right? Then this is test. This is where you write your unit tests. For any other production code base, you have to write tests, and you know why tests are important, and the same goes here. Same is true for here, right? And then this is cmake. All right, any idea what cmake is doing? In case you joined our Definity workshop, we spoke a little bit about what make does, but any idea what cmake? You all know I'm not going to move forward, right? I mean, I'm a pretty adamant person that way. So CMake basically makes it easier to kind of switch between platforms and switch between boards. So let's say right now I know that this entire code works for two boards. It'll be a lot easier to switch. Exactly, customized dependencies. When there are multiple dependencies and there's just a little bit of things that need to be changed and pulled into your for example, you saw the amount of configurations we have here, right? There's JSON files and there is your include files. This kind of gets all of them together, right? And helps you kind of build it all into your one hex file that is finally, loaded onto your board, right? Because you're not loading all of these things to your board. You're loading a very minimal code base into your board, because remember you have limitations as to what's happening. So your CMake kind of reduces all of this, make sure that all your specific code gets made and only that is sent to your target, which is your board. Make sense? This is where it's supposed to find the final file, your .c, and then it's here where it's going to send your target sources. All right. Oh yeah. CMake errors are like, they're basically most of the errors that I get because I I keep updating random things without worrying about dependency changes. And like my Windows computer has like so many things. It has all kinds of, it has a diverse amount of softwares. Okay, so from Unity, Blender, Zephyr, Yocto. I have so many things configured in there. After a point, I lost track as to what dependency was installed for what. And at a point in my Ubuntu, I had like, for some reason, three times CMake installed, and every time it found the path to the wrong CMake. Every time, no matter how many times I configured it. So yeah, CMake is important, and do not play around with the CMake is a lesson I learned. And I'm very careful with all, what dependencies are being installed every time I do an installation now. So again, learning the hard way is very memorable for sure, but it's not a great way to do things. All right, so that's your basic task. So now let's look at how a Zephyr code works. All right, so we now understand the entire structure of our directory. We understand why what file exists and what is the importance of it. All right, now what I'm going to do is, for the sake of ease, I'm going to go to our home and I'm going to simply import a project. All right, I'm going to rather project examples, right? So I'm going to select an example. Let's see. We want it to be Zephyr. There are three more examples. There's driver's entropy, there's Blink, and there's Eddystone. So let's start with Blink, and then if we get the time, we will try the others as well. So while it loads my project, is there any question at this point? Has anyone of you configured the project until this point? It's a very simple process, very rewarding process. So much better than having to configure things from scratch or from, the way I would have ideally wanted you all to do it. I'll take that as a no. We'll take a 10-minute break. We'll take a 10-minute break, and I am the one who's going to be running the Chrome Dino after this as well. So you all are welcome to join me on the stream when we do Chrome Dino. So let me know, and you know the drill. How to enter Chrome Dino? It's basically open a Discord ticket, tag Activewear Miniatures. I'll send you the stream link. All right. Jayesh, we're going to be ending this stream in like 10 minutes. But since you're here, what we're looking into is we're building and configuring an embedded systems project using platform.io, and we're using Zephyr as our framework for the board. We're using the board microbit, and yeah, we're waiting for the project import to complete in my system. But if you have any questions until then, you can let me know, and we're done here. All right. So now you can see it has opened both the projects. This is the live project that we created, and this is the example project that it's been created. All right. So I'm going to remove this for the sake of clean code. So I'm going to remove the folder from the workspace. Now we only have our Blink example. I'm going to close the window as well. And so this is the .ini file, which is basically your configuration file for platform.io. It's basically telling you all the targets it is already configured for. So these are the boards. All right. So let's say I wanted to create a extra board. I can totally do that over here. So let's say I create a custom PCB, right? If I get the NRF51 chip, where is my NRF51 chip? All right. So you can see this is a microbit, right? So the microbit over here, where is the chip? Yep. So this is my chip, right? So this black colored thing is my chip. But this chip is open source and it's available for my custom PCB. So what happens once I create a custom PCB? How do I get go around making the code for my custom PCB? So this is what you do. So this is where you'll come and you'll probably just copy and paste this. Just copy, paste. You will name the board over here. You will define the platform. You will give the board name here as well, and you will give the monitor speed, which is what we will already discuss. It's the baud rate at which your CPU communication is happening, right? And once you do this, it's probably going to throw an error because it will expect some kind of a board library. Once you configure that, again, that's going to be as simple a project process. Just copy the last board, make the changes according to your PCB if there are any. It could be basically the same board. So microbit is also an open source thing. You can just have the same board created with maybe a couple of differences. Maybe the LED pin is different, right? And once you do that, you can just now once you've created this, you can just quickly upload your code as we go. All right, so I'm going to go to a CTRL-Z and hey Khalid. Khalid, do you want to join me on stream? So Khalid is another coach. I am pretty sure you already know that, and he's been conducting streams as well through the week. And all right, I'm going to wait for Khalid to answer. If Khalid's joining the stream, he can just pop into the stream because he already has login, so that shouldn't be a problem. All right, so that is your INI file. This is where you define the code, the number of boards your entire code is capable of running on. So let's say you sit down and create an example code tomorrow. You will make sure that you add all the boards the code is capable of running on in this file. All right. Then next let's look at Zephyr. So you see last time there was only CMake lists in our folder. Now that we have some code and we have boards defined, we have an extra project.configuration file. So let's look at what the project configuration file has. All right. So the project configuration file here has two things configured. It has configuration of the GPIO, which says yes, y equals yes, and then there's config serial, which says no. So what's happening here is we're configuring the GPIOs in our the GPIO port in our port to say that, okay, I'll be using my GPIO port, but I will not be using my serial communication on my board. Where will this get affected? Where will our this project configuration really matter? Remember we spoke about generated include files? That's where this entire yes and no is going to make a difference. All right. All right, so these are our two. So this project configuration is also super important. Remember, or if you're defining I2C, your SPI, any of the buses, Bluetooth UART, what GAT service you want to use, all of the configuration comes here. And as soon as you do, if you even if you don't write any code, you have an amazing set of boiler code ready to go with all your ports defined, all your baud rates, and all your different speeds defined, all ready to go. And two couple of lines of code, and you're sorted to get the application up and running. All right. This basically does a lot of hard work for you on the back end, and which is why we like configuration files. All right. Then again, this is the test file. We don't have any, but this is where you can check out how to write unit tests. Right. Then we have the SRC. Let's come back to the SRC at the last, because that's going to take the longest to traverse through. And you can see all of these are still empty. We'll look into why. And this is the board that it has automatically detected, or rather it is automatically building for, and it has all its files and metadata here. All right. And this is the project checksum, and we have already spoken what a checksum does. All right. So I'm going to come back to StreamYard and see if there are any questions. That's all right, Khalid. I'm the spotlight stealer today, so you can just hang around if you want to, but you're still welcome on the stream. Any questions until this point? Is anyone following along? Is anyone confused as to what's happening? I'll take that as a no and move on. All right, so let's take another last 5 minutes to go over whatever we can. And if there are any questions, you all can come back to me. If not, I'm available next weekend at the FPH. Feel free to drop by. All right, so this is our main file. This is our file that's basically has the code, right? This is your basic, if you're using Arduino, the .ino file equals your src, your main.c file here. All right, so let's make sure it does not get replaced. These are your includes. So there's stepper.h, there's device.h, there's device3.h, and then there is drivers/gpio.h. So when you go here in project configuration and you save this configuration, what your Zephyr does, it is automatically includes all of these things into it. Okay, so device.h and device3.h are basically your structures, your include code structures, which define all of your pin numbers, which pin number already has an alias assigned to it, what pin numbers don't have an alias, so you have to use the pin number itself. Let's see if we can quickly find that device tree over here. There we go. Device tree. There we go. Device tree dot h. Okay. So these are the aliases already given to your different device ports and device structures. All right. Then there's validation and device tree. So if you go through these files, you'll see there's a lot of things already configured for you beforehand. Okay. Let's just do a quick find and go for DTS. All right, so before we move on, and we'll come back to the device tree structure in a bit. It's basically a file which has all the names to all the pin numbers, LEDs. If there, so let's say your board, for example, your microbit has an LED 0 and an LED 1. So when you call LED 0 into your board, it already shows for example over here, if you see, right, define LED 0. So it's taking a DT GPIO label and it's giving you this LED 0 node, right? This is an alias already defined for a GPIO pin, because if you know a little bit about microcontrollers, you know that LEDs, finally you attach them to a GPIO pin. So if a board has a pre-configured LED, let's say for example your microbit over here, let me quickly attach it and show you the LED that lights up, right? So all right, so you see the LED, right? So this is a pre-configured LED, right? So that means that it's basically a GPIO pin which is being turned on and off, right? So this LED already has been given an alias. If you don't know what's an alias is basically a different type of name. It's like a variable name for your GPIO pin. and we're basically just toggling the GPIO on and off. All right. So your device tree basically is all of that with all the aliases defined there. All right. So this should ideally be able to take me to the references. It's not finding any references. So see, this is the GPIO.h, and we should also be able to find the DTS file using one of the references. All right. Anyway, let's move on to the code. So over here you can see that there is and if else in your definition. I don't know if you've seen this before, but we do this to kind of see if there are multiple boards configured for the same code. This is to check which board is using what, and if there are any differences in the boards, tiny differences, you can address it over here. So look at this. What does it say? If the node has status LED node OK, right? Then define LED 0 equal to the label given LED nodes, LED 0 node GPIOs. Okay, and define pin DT GPIO pin as basically we're making sure that the pin is active, and we're setting the flag for the pin. All right, and this flag is what we'll use to turn it on and off. But if it is an error, right, that your board isn't set up to blink an LED, your board does not support a blinking of the LED, then what it will do is and this is what it will throw an error which will say unsupported board LED 0 device tree alias is not defined, right? So that is another very important part of embedded systems, right? If you're writing a code, you want it to run on at least a couple of devices, especially in example code. So this is where your if def really comes into a picture. Even if you're using multiple modules with a single board and you want it to act differently when it detects a different module, this is the type of code that you'll be using. All right, so let's go into our void main now, right? So we have a void main with the argument passed void. Okay, this is a fairly generic way to start a code, so I won't explain this. Let's go into the code now. We have a construct device.def. So when we spoke about the different device tree structures and how the buses are being associated, that entire thing is associated with one structure called the device structure. And this device structure basically has all your buses which you want to use defined. So what happens is it has everything, and you just basically turn them on and off based on what you're defining here. So once you have a device structure defined, you will also bind that device structure to your LED. All right. So for every port that you're using, you'll have a separate device structure. All right. So you first have a device structure, then you are also binding your LED 0 onto your device structure. Then you're checking if the device has been connected. So this code, this piece of code basically, right, is checking if your port, if the GPIO is connected. If it's not, it's going to throw an error that hey, the device is not connected. For example, if you're using an I2C, if you bind your device structure to an I2C, and let's say you're using an I2 device, an accelerometer, right? If it does not detect the device on your I2C bus, it's going to throw an error saying that hey, the device is not found. All right, which Arduino already does, but it's so abstracted you don't understand what's happening for it to be able to detect, right? Then what you're doing is you're creating a return variable, all right, and you're saying GPIO pin configure. So you're configuring your GPIO pin. So first, what are the arguments here? The first argument is your device structure, all right. So let's just type it out. The first argument is arguments equal to first is your device structure, which you defined and you have bound it to your GPIO structure, all right, your GPIO pins. Then is your pin number, all right. Then is your GPIO output active, which is basically you're configuring the GPIO to be output. In case of your Arduino, you do a pin out, right? In this case, you're doing a activate output or activate input. And then what you're doing is with this part, you are associating the active part to the flag. So whatever the flag says is what the state of the GPIO should be. All right. If your return variable is less than 0, it's gonna return. All right. This is basically an error check again. This is the same thing. It's checking whether the GPIO has been connected properly or not. All right. Now this is your while loop. This while one is what is going to continuously keep going until your code gets executed. All right. So GPIO pin set. Now you're setting the GPIO first on. So what's happening is GPIO pin set. Again, the device structure. Let's write the arguments here again. So arguments equal to, first is your device structure again. All right. Then you have your pin again, which is basically your LED 0. All right. Then you have your integer LED is on. So integer over here is basically us returning 0 or 1. So I'm sure if I hover over it, it's going to show me a 0 or a 1. So there's bool LED is on, and if you go to this, true, right? Your LED is on is equal to true. And integer of LED is on is basically it's going to convert true into integer, which is going to be 1, which is our digital output, right? So when you write digital dot output in Arduino equal to high, what you're doing is you're basically passing a 1 in your GPIO, and it's toggling the LED high by giving it 100% voltage of that pin, which is either 5 volts or 3.3 volts based on your board. All right. Next, if LED is equal to on, LED is equal to on is equal to not LED is equal to on. What's happening over here is basically we're toggling true and false, right? So if it's true, it will become false. If it's false, it will become true, right? If it is true, it will become false, and if it is false, it will become true. All right. What's the last thing that we're doing? We're doing a Kms Sleep, which is basically your delay equivalent to your Arduino, and this is the sleep time. All right. I just saw this comment. PS for Mario. Are you confused about what we're doing? Are you confused about what's happening? All right. And this is your team sleep time in MS, which expands to 1000 milliseconds, which means it's going to sleep for exactly 1 second. All right. So this is sleep time dash delay in milliseconds, which equals to 1 second total. So fairly simple, right? This is a fairly simple code. What I'll do is I'll upload this commented code. I'll comment all of this also as to what it means and upload it to GitHub for you all to be able to follow along. Now, I know this was a bit of a stretch in terms of how much we've covered today. But if there are any questions, if you all get stuck in following any of the steps, do let me know. I'm going to quickly walk you through the building and uploading process. It is so easy on Zephyr, it will blow your mind. Okay, so what you want to do is you want to come back to your home here. All right, it's going to show you all of these things, right? What you want to do is you want to expand this. All right, this is basically all the projects available. Now, based on what board you have, we have neither of these boards, but I'm just going to take one random one. For example, it will throw an error when I try to upload it, but that's okay because we're connected to a microbit. All right, so it's going to show you all the different tasks available. So to build this entire project, this is what you need to do. I've literally clicked on build. All right, it's going to build you the entire project. Okay, and once it's done building, you can just click on upload and it'll upload. All right, that's how simple it is to use platform.io. I promise you, there's nothing that you're going to find that it works in an easier manner except maybe Arduino, right? So this is a much better way to go about programming your boards, even if it's an Arduino board. Try using this. There's a lot more, in-depth control you get over your board over here. All right, so there you go. This is done. Yes. All right, so the building is done. Now when I click on upload, it's going to try to upload. It's going to fail, Abhi, because we are not connected to the right board, but that's okay. The building process remains the same. Building and uploading process remains the same. All right. Okay, for some reason it was able to upload the code not meant for microbit onto microbit, and that is not something that you should do ever. Don't cross upload codes, even if it's allowing you to do so. But yeah, it's happened here, and it's not exactly a good thing, but for the time being, it's not a bad either. thing, because this is a simple blink code, it won't cause any harm, so that's okay. All right, so that's all, folks. This is how simple it is to get started with an embedded systems project or true embedded systems project. And if there are any questions, I can take abhi. Otherwise, if there aren't, you all know where to find me on Discord, on Twitter, wherever you all are comfortable reaching out to me, and we can help you out there. I understand this was a tad boring, especially with my connection issues, but I'm so glad for all of you all who stuck around till the end, and anyone who joined. I'm glad you enjoyed. I hope you enjoyed rather at this point. But yeah, if there are any more questions that I can take regarding finding makerspaces, or if you want me to help you find and connect you to makerspaces, let me know. I'll be happy to do so. All right. Any other questions? Any other comments? Feedback is always appreciated. If you'd like me to take it in a certain different way, explain it in a different way, happy to do so. All right. Any questions? If not, thank you, Aman. I'm really flattered. I know this is you being super nice, because I know it was a pretty I don't know, interrupted session. I would have liked it to be a little more interesting for y'all. Also, I had figured out how to give you remote control, so y'all could have uploaded your code onto my microbit. Maybe let's do it in the next weekend. If I ask Mary, we're anyway going to be running streams from the next FPH, hopefully. So I'll kind of schedule it such that y'all can just come on board. We can continue this, and y'all can upload your codes to my board. All right. If there are no further questions, I'm going to stop the stream. So the next. Thank you so much for understanding. Awesome. So here's the thing. The next stream is also mine, which was supposed to start 5 minutes ago. So let's take a quick 10-minute break. All right. Let me get some water. And we'll come back for Chrome Dino in exactly 10 minutes. So I'll see you all then. You all can join me in the stream for that. We'll play Chrome Dino together. Again, I suck at games. I suck at most games. So it's going to be fun. I'll see you in a bit. All right. See you all, folks.